Just okay. Hi everyone. We're gonna go over some of these questions on the 5-4 practice on the AP Classroom for us. And I was asking number 6 and 22. So let's go and do number 6 first. The graph of the function f is shown above, -2 to 2. Okay, so -2 to 2, got it. -2 to 2. Let g be the function defined by the integral of f between 0 and x. Okay, so we're taking the integral of x between 0. So let's say if we're going to the right, we're going to add. Like that would be an example of us going from 0 to 2. On what open interval is g negative and decreasing? Okay, so two things we want to make sure that we're caught up. We want to make sure that g is negative. So the answer to g is less than 0. So up to what point are we negative? And also, are we decreasing? That means g prime of x is also less than 0. Okay. Now, these are just straight to basic calculus things I'm thinking about. They asked us at what value of g is negative, and the answer to g is an integral. Okay. And again, the second part is decreasing. When I hear the word decreasing, I'm thinking automatically the derivative. Like, that's just how I think of it. Decreasing, that's a derivative. If I take the derivative of this problem, if you remember, the derivative g prime of x is the derivative of this. So that's just f of x. Right? We just plug in it. That's the fundamental theorem of calculus. So when is this less than 0? Okay. First, let's go ahead and answer the first part. At what points are we between 0 and x? So let's look on the right side. That's the easy part over here. Easy part over here. When are we negative? Well, we are negative here. Okay. And as we are negative, are we still negative here? And the answer is, let me ask you that. Imagine if, what is the area from here to here? This is a nice triangle for us. So 1/2 base times height, the base is 1, the height is -2. Our area is -1, right? 2 divided by 2 is 1, -1. But right when I step here, are we still negative? We are still negative, aren't we? Because just because I pay you back a little bit, you haven't paid me completely back yet. What if I add some more? You haven't paid me completely back yet. You're not paid back till all the way to 2. So it turns out we are negative from 0 all the way to 2. Okay. Now, again, why am I saying this? Why aren't we just here? Well, again, one reason is the first part is saying when are we completely negative? We are the sum of the integral, right? This is the integral, right? So the sum, we're adding super negative, this is all -1. But right when I jump over here, are we still negative? The whole sum, yes, is still negative, still negative, still negative. We haven't paid back our debt till we hit 2, and now we're even at 0. So I'm looking at this as when on open interval, just to the right side, from 0 onward, we're going to be negative. Now, what about on the left side? What if I say this area over here? This is all negative, right? But would that satisfy our condition? Well, our function was written as g of x is equal to the integral between 0x of f of x dx. So what happens on the left side? What if I want to look at -1? What if I write integral from 0 to -1? Would that be negative? Well, I'm going to spin this around, and this is negative from -1 to 0. Okay, so let's actually look at what this would look like. What is the area from -1 to 0? Just as an experiment. This is just an experiment. Let's see. From -1 to 0, would that be a positive answer or negative answer? If I summed from -1 going this way, that would be a negative answer, right? But isn't that also a negative? So a negative and a negative become actually a positive. So that would not have given us a negative area. What if I went all the way to -2? So I'm running out of space. If I wrote the integral between 0 and -2, why did I not write -2 and 0? Is because this is what the function told us. The function said go from 0 onward. But if I'm going in reverse, we're going to have to spin this around to say negative integral from -2 to 0. We know that this answer here, from -2 to 0, that's all negative y's. that's a negative of a negative is still, sorry, not still, it's positive now. So we know that is not counted. So the first condition is met. The first condition says that we're actually all going to be negative from 0 to 2. Now, of this point 0 to 2, which of this is decreasing? Which of this has f as a negative value? Well, it looks to me the actual graph values are all negative. Just here, negative, 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 negative. So my answer, I would say, is from 0 to 1. So let's look at number 22 now. The slope field for a certain differential equation is shown above. Which of the following could be a solution of the differential equation with the initial condition of y at 0 is 1? So y at 0 is 1. I'm going to put a dot there. Whoops, let's go ahead and screenshot this. Y at 0 is 1. Okay. So which of these could be it? So now if you look at here, if I start drawing my graph, it looks something like that. Huh? Doesn't look bad, right? So which of these could this have been? Could it have been a cosine? Cosine graphs kind of look like that, doesn't it? So maybe, okay, maybe. How about an x squared, a negative x squared? Does that look like a negative parabola for you? Does it look like it's going to force downward? It doesn't look like it's going to be a negative parabola for me, because that would have just meant it had to keep going. Okay. So it doesn't look like a parabola for me. E to the x, we all know what e to the graph look like. It looks like that, straight up. And my graph does not look like it's taking straight off. Okay. Next one, square root. This is actually the equation of a circle, if you guys didn't realize it. It's going to be y squared is equal to 1 minus x squared, which is x squared plus y squared is equal to 1. That's actually a circle. And if you see the slope fields for a circle, they kind of look like that. Okay, so that's an equation of a circle. And the last one is this guy here. Now, if you notice, it's 1 over 1 plus x squared. So will this ever be 0? 1 over 1 plus x squared. Can you make 1 plus x squared ever equal to 0? Answer is never. So we don't have a problem here. If you plugged in 0, you would have gotten 1. If I plugged in 0, you would have gotten 1. Actually, for all these, if you plug in 0, you would have gotten 1, right? All these you would have gotten 1. And this graph is this guy here. Now, if you're not sure why it is, if I say 1 over 1 plus x squared, give me a big number for x, like 10. Isn't 1 over 10 squared is like 101? Isn't that a big number, small number? So as x gets bigger, the fraction makes it go smaller. As x gets bigger, the fraction makes it smaller. The negatives look like the right positive side because the square makes the negative side look like the positive side. So it is actually D. Or E. Yeah, E. Sorry. 1, 2, yeah, E. Okay. Okay, let's look at number 25. The function f given at this crazy function has a relative minimum. Now, how do I find this idea of relative minimums and maximums? And if you're not sure, hey, look, that's it. Oh, darn it, sure. Like, no joke, I think of this. When I hear minimum, I think of a parabola. Here's a parabola. Isn't there a minimum here for a parabola? How do you find that? Oh, it's when the slope is 0. So I got to look for my derivatives. And when the derivative is equal to 0, we know we have a critical point. And if it goes from a negative to positive, that's how we figure out on the derivative. If not, how in the world are I supposed to find a minimum and maximum here? It's not like I have a vertex. It's not a parabola, okay? So I was like, oh my gosh, this is crazy. But if I know it's just a derivative set to 0, let's do it. 9 times 2 is 18 over 3, x to the negative 1/3. That's me taking the derivative, plus 3, okay? Let me double check. 9 times 2 over 3 is 18, yep. And then minus 1 is 1/3, right? And make that equal to 0. That's it. Let's go ahead and finish it off. If I move the 3 over, that's a negative 3. Multiply by 3. 18x to negative 1/3 equals to, we said 3 times, is 9, I think, right? Negative 9, so we minus 3, and then we multiply by 3. That's 9. We're going to divide it by 18. Divide 18. 8 is equal to, sorry, what am I doing? I'm sorry. x to negative 1/3 is equal to negative 9/8, or so 1/2. Okay. And then I'm going to, a couple ways you can do this. You can either rewrite it as 1 over the x to negative 3 if you want to look at that. Oh, darn it. Like you can do it this way if you want. Okay. But I'm going to just multiply both sides, negative 1/3. Oh, sorry, wrong one. Oops, not 1/3, 3. Okay, let's do that. And that's going to be x is equal to negative 1/8. Now, this, okay, so, okay, well, is it true that this is a relative minimum? Negative 1/8? We're going to plug in a number to the right and a number to the left. I'm going to plug in 0 because I'm the laziest guy you know. If I plug in 0, that's positive. Okay. If I plug in anything more than 0, if I plug in 5, 6, 7, 8, let's plug in let's plug in 8 because I know what the cube root of 8 is. 18/3, and I'm going to plug in negative 8. So negative 8 to the negative 1/3 plus 3. This is the cube root of negative 8. So it's 1/2 negative 18/3. This becomes 9. 9 divided by 3 is 3. 3 plus 3. Oh, wait. Darn it. I lost it.
It's x equals negative 8 because it's negative 1/2 to the negative third.
Negative third. So, oh, thank you. We flip it around. Oh my gosh, what the hell? That's why I was, gosh. Thank you. I'm doing this too fast. So negative become it flips it around, right? So that's why it's a negative 8. So it's 8. So the zero's over here then. If I plug in 0, we want to look for a minimum, right? So minimum goes this way to this way. So it's negative slope, 0, positive slope. But if I plug in 8, then 0's over here then. And if I plug in 0, wait, we can't plug in 0. So we have to plug in something a little closer, because this is really 18/3, which is 6 over x to the cube root of x. And you can't plug in 0, so you can't plug in 0. So we can plug in 1 instead. Negative. No, here's zeros on the right. So we can't plug in 0, but we can plug in negative 1 and negative 9, I guess. Negative 9, negative 27. I'm going to rewrite this. This is simplified to become like this, right? So if I plug in negative 1, this will be negative, negative, negative. No, that's not working for me. I plug in negative 1. Negative 1's on the right side here, right? If negative 1's on the right side, sorry, sometimes I break. This part is good. This is, if I plug in negative 1, it's going to be 6. Negative 6 plus 3 is negative, which is not what I want. See where I messed up. Give me 1 second. My brain crapped out real quick. Okay, so here's my function. Where's the relative minimum? Okay, so what happens on my left? Okay, wait. Let me think. What's going on here? This is negative. So I'm getting a negative. Let me think. Negative 8 is my critical point, right? But here's my, if negative 8 is my critical point, if I plug in negative, we can't plug in 0 so far, because if I plug in 0, that doesn't exist anymore. I can plug in negative values. I can plug in positive values. If I plug in negative 9, what does that look like? But I would rather plug in negative 27 because I'm cheap. Negative 27 goes in here, gives me 6 over negative 3 plus 3. That's 2. Negative 2 plus 3 is 1. So this is positive on my left side. If I plug in negative 9, though, let me try this on calculator real quick just to make sure I'm not too off. If I plug in 9, what's 6 divided by negative 9 cube root of 1 over 3 negative. And that's going to be super negative. Shoot. Sorry, I'm